Hi, Michael Grossberg here. I wanted to talk to you about an aspect I find that beginner programmers often struggle with, which is that computer languages are very, very picky. And I'm going to give you a few examples. So first of all, let's think about human language. If I say something like, me happy, you don't have a problem understanding what I meant. Or if you saw somebody write the sentence, somebody ate my bag of potato chip, you don't become confused because, not plural. You know that I probably meant potato chips. Computer languages are different. Unfortunately, or fortunately, they are very, very specific. So small errors can have huge consequences. So let's just take one example that actually a student just brought up recently as confusing. In Python, when you say print hello, right, you can do that, and you get back the message hello. That's fine. And then if you say print hello, but without the quotation marks, you get an error. That's because hello is a string, according to Python, but hello without the quotation marks is a name. It names the box in memory that's supposed to hold something, and maybe we didn't put anything in that box, in which case we're going to get an error because it doesn't know what we want to print. So print is a function that takes a string, and it could take a name if the name had a string in it or it had some other thing that it knows how to print. Just to give you an example of the kind of weirdness that we're talking about here, suppose that you had a name hello and you set it equal to the string goodbye, and then you said print hello. Then you would see goodbye come out on the screen. So print hello prints goodbye. So the issue is that strings and names are very different things. Again, a name is a label on a box in memory which could hold an integer or a boolean or something more complicated, a string. And a string is something in quotation marks, and it's a bunch of characters. It's a sequence of characters. Okay, so this reminds me of this famous painting of Rene Magritte where he shows a pipe, and it says, and I'm going to do the terrible injustice to the French, ceci n'est pas une pipe, which means this is not a pipe. Of course, it's a picture of a pipe. It's not actually the pipe. So just keep in mind that the name, it refers to something. It's a reference to something, but it is not actually that thing. Okay, let me give you another example of one of the ways in which computers can be really, really picky. So another way is that with the equal signs, basically, the equal sign is not as equal as you think it is. So if you have x equals y, okay, in math, that's the same as y equals x, but not so in computers, or at least not in Python, for example. So if you write x equals y, what it actually means is that I'm going to take stuff out of y, out of the box named y, and I'm going to put it into the box named x, copy of it. Okay, so if I have the statements x equals 3, that means put 3 into the box called x, and then I say print x, we're going to see 3. Then if I say, let's look at the box named y and put a 4 in there, okay, we can do that. And then if I say x equals y, that means take whatever was in the box that called y and put it in the box x, perhaps overwriting or basically erasing what used to be in there, and now print it. So now print x says 4. Now, just to contrast that, if we did this the other way around, in other words, everything else is the same, x equals 3, print x, and then x equals 4, but now we said y equals x, we're going to copy whatever was in the x box and put that in the y box, and then we'll just get 3 again because we didn't change x. So depending on whether it's y equals x or x equals y, we get different things. They are different. And in fact, what they are is an assignment operator. That's what they're called. And that's why if we write 4 equals 5, which is absurd in math too, but 4 equals 5 in this case would mean let's take 5 and we're going to assign it to 4. But 4 doesn't name a box. It's the number 4. And how can we assign 5 to 4? They're different things. So that's why you get an error message when you type that. Now, there is something which is symmetric, which is a little bit closer to math, which is the equals operator. So if we said x equals y, well, it isn't quite the same as math where we're saying, x equals y. But it is like asking a question, does x equal y? Okay, which is the same as the question, does y equals x? So we can do that, and it gives us back a Boolean, a true or false value. If they're equal, true. If they're not equal, false. So that is a little bit closer. But we have to keep in mind that equals is an assignment, and equals is a test, whether two things are equal. Okay, so now the next thing is to consider white space in Python. That's another tricky area where people can get confused. So one thing that there are these invisible characters. This space, of course, is kind of an invisible character. It's called white space, just even though that our background could be black or green or whatever, but it just means sort of the gap between characters. But it's a particular kind of a gap. There's other gaps. There's a tab character, and a tab character puts some variable space between, depending on the setting of the machine, the editor or whatever you're using, how big a tab could be. And there's a new line, which means go to the next line. Then there's the return line feed, which also means go to the next line, but it's kind of a different convention. So there's a bunch of these invisible characters, and you can get in trouble because very often we can't see these characters, and we think maybe they're not there or they're the same. So just keep that in mind. Invisible characters can get us in trouble, and particularly important in Python because white space is meaningful. In many programming languages, the white space doesn't mean anything. But in Python, it's the structure of the program has to do with the white space. So if we write an if statement, then it will be we show the block of code that the if refers to. If this is what we do by using an indent. And we have to be very careful not to unindent that, or the program won't work. And we could get an error message, or it might, even worse, it just might work not as we expect it. So we always have to be very careful there. And one thing that helps us if we follow it is that we should probably use 4 spaces. That's the convention. 4 spacebar, 4 of them for indenting Python code. Now you could use tabs, and that's fine, but the problem with tabs is that depending on what editor you're using and depending on a bunch of things, tabs could be big or tabs could be small, and tabs could adjust in sort of unpredictable ways. So it's usually best to use the space key. Now there's a guide that everyone who's programming in Python should read. It's called PEP8, which is Python Extension Proposal 8. And it's the style guide. It's kind of the good manners guide to Python. And it answers a lot of questions about, like, should I do this or should I do that? Not questions about, like, would this work, but questions about, whether this would be good Pythonic style. So I encourage all of you guys to read that. And if you want to see something a little funny about tabs versus spaces, you could Google Silicon Valley tabs versus spaces, and there's a scene with one of the main characters and his girlfriend sort of arguing about whether it's better to have tabs than spaces. All right, so the last little persnickety thing I'm going to bring up are square brackets, curly brackets, and parentheses. So this is going to kind of go into sort of a little bit more advanced stuff we're going to get to a little bit later. But I just want to give you an idea that these things are very, very different. So you will see the round brackets come up in many, which we call parentheses, come up in many different contexts. So one context they come up, of course, is like they come up in math. You can group things with the parentheses. So you can say 5 times 3 plus 6, for example, and that's fine. And you can keep going. You also see them when we have either what's called a call expression or a function call, meaning that we have something that we can put in it, and then we either get back something or it does something. Like the print statement. We put in a string or we put in a number and it does something. It prints it to the screen. So that goes inside of parentheses. So that's another use of parentheses that you'll see very commonly. Another time you might see this, more of the grouping kind of thing, is when we have something that's kind of going over a line and we want to just make sure that it doesn't break, so we'll put parentheses around it, and the Python is smart enough to say, well, you haven't closed your parentheses yet, so let me go look a little ahead, maybe if it's on the next line, and that'll let you to split things across multiple lines with a parentheses. So that's can also be a little trick if you want to do that. Another kind of use of the parentheses, and this gets into that kind of more advanced stuff that I was talking about, is in a data container. So a data container is something in which we've talked about ints, and we've talked about strings, and we've talked about booleans, but these things can be put inside of a container that can hold a bunch of things. So we could have a bunch of things kind of in a sequence, and one of those sequences is called a tuple, and a tuple can be written with parentheses. So here we could have a tuple maybe with a string and then a number, and we separate it with a comma, and we put parentheses around it. That's a tuple. So that's one kind of data container. Now, I told you there were square brackets too, and there's another type of data container that's actually very similar to a tuple called a list object, and it has square brackets. So we have something and then comma, and we can have something else. We could have a few of these, both in the tuple and a list, and they work very similarly, for the core functionality of holding things. But there are important differences, and we'll get to that in another, later in the course. But the point I'm trying to make is they are very different, and the square brackets and curly brackets. Now, if you want to get something out of a list or a tuple, right, you use the square brackets. So you say square bracket, and then starting at 0, 0 is the first element, 1 is the second element. You count. You say, okay, I want to print the 0th element with a square bracket. And so here the square bracket comes in, not the round brackets, and that actually will give you the first element if it's a 0. If it's a list, same thing, square bracket. Even though the tuple was created with round brackets, you still exit with its square brackets. And the list still exits with square brackets. Now, you may ask, what about the curly brackets? Well, the curly brackets is another kind of data container, and it's called a dictionary. And this kind of data container has the ability so that instead of accessing things by a number, like is it the first, is it the second, is it the third, you can access it by a name or something like that, some other actually immutable item. So you can just say, number of turtles, and you can ask it again with the square brackets, even though it was built with curly brackets, show me number of turtles. And in the case that the dictionary was built with 999, let's say, is the value for a number of turtles, it gives you that. So again, we've got 3 different data containers. They're all referenced with different kinds of parentheses. It's very important. Parentheses are going to trip you up all the time. Sometimes you'll close a parentheses or you'll close a square bracket when you meant to close it with a round bracket or parentheses, or you close it with a curly bracket when you meant to close it with a round bracket. You'll get a syntax error, or you forget to close one of them, and that's another kind of a gotcha. So just be careful with that. Just to sum up, what I want to say is that it's really important to be aware of the fact that unlike when you're talking to another human being or you're writing to somebody in an email, computer languages are extremely picky. A single character will trip them up. So what I often find is that beginner programmers will get very, very angry, and they will say, well, Python is broken, or if you're using Jupyter Notebook, Jupyter Notebook is broken. And what really happened was they didn't close the parentheses, or they weren't really careful about white space, or something like that. So your assumption should be that you're wrong, that you did something just a little bit stupid. I mean, just a little mistake you made. Because 999 times out of 1,000, that will be the case. And the reason why that's important is there's no reason to get angry. You want to know that you made a mistake, because then you know how you could fix it. You can read through your code, or you can try different techniques to identify where that mistake is, read the error messages carefully, and find it. And that will get you back into something that works. Okay, thanks very much. I hope that was helpful.